Hi everyone. Today we're going to go through some questions where we determine the electron configuration of an element. Let's get started. Now, the first thing you're going to want to do once you get an electron configuration question is to label your periodic table. This is going to give you the best way to make sure that you're getting the correct answer. So, firstly, you want to label the first two columns as S. Then you want to go over here and label these 6 columns as P. Then all of these in between you are going to label D. And these last 2 rows are going to be F. The next thing you want to do is, maybe in a different color, number these periods. 1, 2, 3, 4, 5, 6, 7. And down over here, these last 2 rows, you're going to number them like this. So this one is 4 and this one is 5. So it's not clear, I'll write it here. So that gives you the tools to help determine the electron configuration of any element. So let's say, for instance, you're asked to find the electron configuration of sodium. Okay, so this is what you're going to do. You're going to write Na, and then you're going to start off with 1 over here, 1, and then you're going to cross that off. That's 1s, 1. And then we're going to go over here to helium, which is also included in the S. And then that's going to be 1s2. And then we move on to our second row right here. So that's going to be 2s2. And then we're going to cross all of these off. 2p1, 2, 3, 4, 5, 6. That's 2p6. Until we get to sodium, which is in the third row, and it's under the S, so it's going to be 3s1. So that's the full electron configuration for sodium. We're going to try a couple others. Okay, our next question asks us for the electron configuration of carbon. So carbon is right here under the P label. So what we're going to do is start off with carbon. Then, as always, we're going to begin with 1s1, 1s2, so that's filled. Then we're going to move on to the second row. 2s2. And then we get here, so 2p1, 2p2, and then we stop there. That is the electron configuration of carbon. For the next one, we're asked to find the electron configuration of sulfur. So write sulfur down here. And we fill up 1s1, 1s2, so that's done. And then we get our 2s2. And then all of these are full, so 2p6. Then we go down to the 3s, so we get 3s1 and 3s2. So those are full. Then we move on to the p orbital, so we get 3p, 3p1, 3p2, 3p3, and then 3p4 is where sulfur is. So that is the electron configuration of sulfur. Our next example is a bit different. It asks us to find the electron configuration of titanium. Titanium is down here under the D label. So what do we do differently? In this case, we're going to start off the same. So we'll write titanium right here. So 1s2 is full, so we'll write that, 1s2. And then 2s2 is also full. So are all of these. So we'll write 2s2, 2p6. 3s2 is also full. And so do we get 3p6 as well? Okay, so we'll write 3s2 and then 3p6. So this is where we're at right now. So we can either go for S2 like this and then continue onto here and then do these, but that wouldn't be correct. So when you're filling out these electron configuration questions, once you finish past the 3p6, you go down to the 3ds. You don't go to 4s2. I know it seems that way because you go down from the 3p6, you finish that, and you want to go down to these ones, but that's not the case. You're going to be going down to this part right here. So what you're going to do is fill out 3d2, and then 3d2 because that's what it takes to get to titanium, and then we'll go to the 4s1 and 4s2. So we're going to fill those out. But it's important to know that you're going to be filling out 3d orbital before you fill out the 4s orbital. So let's say you're asked to find the shorthand or the abbreviated electron configuration for titanium. This is our full configuration right up here. Let's say we're asked to find the abbreviated one. So what you're going to want to do is find the symbol in the noble gas group that comes in the row that precedes the element that you're looking at. So this is our noble gas group for us, right? These rows right here. So we have, out of all of these, we have to pick the one that comes in the row preceding to titanium. So just looking at it, you will see that it's argon. So what we're going to do is, as always, start off with Ti, and then in square brackets, we're going to write Ar for argon. And then from there, we're just going to go off like we normally do. So 3d2, 4s2. So essentially, we're just starting off from here. And then we're going to count our 3d2 right there. And then we're going to fill out the 4s2 orbitals. So it's pretty simple as long as you just pay attention. You just need to be able to pick the right symbol in the noble gas and then carry on from there. So now that you know how to do the ones that we went over, it's important to know that there's two exceptions to this rule where what we learned isn't exactly what happens all the time. So we're going to go through both of those exceptions that you need to know. Now it's very important to know these two exceptions because they often come up as test questions. Now the first one is chromium. So here's what's going to happen to the configuration of chromium. We'll write the full electron configuration. And if you like, you could try and fill out the electron configuration using the steps that we used and see what you get, and then continue the video to see how it differs based on the new rule. So like always, we're gonna go like this till we get to where we want to be, and then we're gonna go to the 3d orbital. So 1, 2, 3, 4. So right now I'm doing it based on how we're accustomed to doing it on 4s2, but this is actually incorrect. This is not the correct way to go about solving it for chromium. So chromium is actually one of the two examples that are exceptions to this rule. So this is what the electron configuration of chromium is actually going to look like. Gonna get 1s2 and 2s2, 2p6 as normal. So are the 3s2 and 3p6, but this is where it changes. So instead of 3d4, we're actually going to get 3d5. And this electron is going to come from here. So instead of 4s2, we're going to get 4s1. Now this is related to the element preferring to be more stable by having 5 electrons over here in the 3d5 rather than having 3d4, because it's very close to achieving, well, basically this is what we want. So by getting the 3d5, we're able to get this. And that's a much more stable form, and chromium prefers that, so it's going to take that electron from the 4s2 and it's going to put it right here. So that's the first exception to the rule. Now the second exception to the rule is copper. And it's going to behave very similarly to the chromium. So I want you guys to write down what you think the electron configuration of the copper is going to be. So first off, I'm going to start with writing the incorrect electron configuration that some might assume is correct if they didn't know it was an exception to the rule. It's 3s2, and then 3p6, 3d9, and 4s2. So it turns out that this is also incorrect. Wrong. It's going to behave similarly to the chromium, whereby it's going to take one of those electrons from the 4s2 and it's going to become 3d10. So let's write out the full electron configuration. 6, 3s2, 3p6. So it's going to become 3d10, 4s1. Because it really prefers to have that 3d orbital filled out rather than having 3d9, because it's only one electron away from becoming a lot more stable. So instead it takes one of these electrons from the 4s2 and then it becomes 3d10. And just a quick note, all of these elements that are in the same column as chromium and copper are going to behave the same way. So they're going to take one electron from the 5s or the 6s or the 7s, and they're pretty much going to add an electron so that it becomes much more stable. A lot of the times in tests and exams, you're going to be seeing chromium and copper, so make sure you keep an eye out for them, because a teacher or a professor might be trying to trick you with them. So we're going to try one more example. Let's say we're asked to find the electron configuration of erbium, way down over here. So as you can see in the periodic table, there's this section right here where it says 57 to 71, where basically all of these elements they compose this part right here. So essentially, let's say what we're going to do is we're going to find the electron configuration of erbium. And we're just going to do the shorthand configuration because these questions are pretty rare, but we're going to do one just in case. So we'll start with Xe because that's in the preceding row and it's the noble gas from that section. So I'm going to write Xe. And then what we're going to want to do is, as usual, we're going to start off with our D group of elements. So we're going to count. What we're going to do is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So just like before, this is going to become 4F12. And that's why it's so important to number the periodic table once you get it, if you're in a test, for instance, because this will help you keep everything organized. So we're going to get 4F12, and then because just like we do whenever we get like a titanium or something, we're going to fill out the 6s orbital. So both of those are full, and we're going to get 6s2. And that's the the shorthand electron configuration for erbium. Thank you guys so much for watching. If you have any questions, as always, feel free to leave them below. If you have suggestions for new videos, let me know as well. Thank you for watching.